Today we will be discussing Newton's 3 laws of motion, so jump in for the car ride of your life. We will be looking at this clip of a car hitting a brick wall and applying the laws as they all exist in this very same scenario. We will begin with Newton's first law, the law of inertia. This states an object at rest or in motion will remain in that state unless acted upon by an external unbalanced force. Going back to our example, when a car makes contact with a wall, an unbalanced force acts upon the car which decelerates it. Now, imagine if the previous scenario involved a person sitting in the car. If the passenger in the car is wearing a seatbelt, the passenger shares the same state of motion as the car, so the passenger will decelerate as the car does. However, if the passenger is not wearing a seatbelt, the passenger in motion would continue in motion. Newton's second law of motion states that force is directly related to mass and acceleration. Formally, it is referred to as the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. But what does this mean? This statement can be summarized by the mathematical equation force equals mass times acceleration, or F equal ma. Basically, the higher the mass of an object, the more force is required to accelerate it. In our example, the car is 2,000 kilograms traveling at an acceleration of 27 meters per second squared. The resulting net force is 54,000 newtons. At this force, it is not enough to break through the wall because the wall is a larger mass than the force exerted. Let's compare this to a scenario where the car has a larger mass. This car is 4,000 kilograms, traveling at the same acceleration of 27 meters per second squared. The net force is 108,000 newtons. As you can see, as you double the mass, the force will also be double. The larger force is able to easily break through the brick wall. Newton's third law of motion states that for every action there is an equal and opposite reaction. Basically, the car is object A. The wall is object B. In this interaction, there are two forces acting on the interacting objects, referred to as action and reaction forces. Object A, the car, exerts an action force by crashing into object B. Object B, the wall, must exert an equal and opposite reaction force directly back at the car. As a result, in our example, you can see the car is pushed back and crumpled in the front from the car absorbing this reaction force.